Hello everyone, this is BSc TY class. Yesterday we have discussed some properties of the complex number. Now today we are going to discuss some further properties, additional properties of the complex number. So further properties. Further properties of the complex number system, that is complex field. So yesterday we have discussed the complex numbers is a field. Now first, if Z1, Z2 belongs to set of complex numbers and Z1 into Z2 is equal to 0, then Z1 is equal to 0 or Z2 is equal to 0. Now proof. This implies that if the product of the two complex numbers is 0, then either Z1 is 0 or Z2 is 0. Let Z1 into Z2 is equal to 0 and Z1 is not equal to 0. Now consider the product of two complex numbers is 0 and the first term of the product is not equal to 0. If Z1 is not equal to 0, then Z1 inverse exists. Z1 inverse exists. So multiply Z1 inverse to this product. So Z1 inverse into Z1 into Z2 is equal to Z1 inverse into 0. So associativity of multiplication Z1 inverse into Z2, this is equal to 0. So this implies Z2 equal to 0. If Z1 is not equal to 0, then Z2 is equal to 0. Hence the proof. This implies that set of complex numbers is an integral domain. So this is the concept in linear, that is the ring theory. So product of two numbers of any set are 0, then at least one of the two is 0. Now second property, division by a non-zero complex number. Second, division by a non-zero complex number. Now let Z1 is equal to x1, y1. Z2 is equal to x2, y2 belongs to the field C. Now we have, if Z2 is not equal to 0, then Z1 divided by Z2 can be written as Z1 times 1 by Z2. It can be written as Z1 into Z2 inverse. So we can calculate this. If Z1 is equal to x comma y equal to, and Z2 inverse is what? The inverse of this. So it is what? x2 comma x2 square plus y2 square and minus y2 divided by x2 square plus y2 square. So we can further calculate this. Now this is equal to x x1 bar. Z1 is x1 bar. x1 x2 minus y1 y2 divided by x2 square plus y2 square comma. Now y times this y1 x2 minus x1 y2 divided by x2 square plus y2 square. So Z1 divided by Z2 is equal to Z1 into Z2 inverse can be written as x1 x2 minus y1 y2 divided by x2 square plus y2 square plus I times this term y1 x2 minus x1 y2 divided by x2 square plus y2 square. So we can divide any complex number by non-zero complex number. Also Z1, another form of Z1 by Z2 can be written as Z1 divided by Z2 is equal to x1 plus I by 1 divided by x2 plus I by 2. So it can be written as x2 minus I by 2 divided by x2 minus I by 2. So it becomes x1 plus I by 1 into x2 minus I by 2 divided by this x2 square plus y2 square, a plus b, a minus b, a square minus b square. Now further multiply x1 x2 plus y1 y2 divided by x2 square plus y2 square comma y1 x2 y1 x2 minus x1 y2 divided by x2 square plus y2 square. So this is the another form, another method to calculate the division of two complex numbers. Now the third property, Z1 plus Z2 divided by Z3, Z1 plus Z2 divided by Z3 can be written as Z1 divided by Z3 plus Z2 divided by Z3, where Z3 is not equal to 0. It can also be written as 1 by Z3 plus Z2 times 1 by Z3. It can also be written as Z1 into Z3 inverse plus Z2 into Z3 inverse. So these are the same. Now 1 by Z2 is equal to Z2 inverse. Fourth, 1 by Z2 is equal to Z2 inverse, where Z2 is not equal to 0. If Z2 is equal to x2 plus I by 2, then inverse of 1, Z2, this can 1 by Z2 is equal to 1 by x2 plus I by 2. It can also be written as 1 by x2 plus I by 2 into x2 minus I by 2 divided by x2 minus I by 2. So this is x2 minus I by 2 divided by x2 square plus y2 square. So it can also be written as x2 divided by x2 square plus y2 square minus I by 2 divided by x2 square plus y2 square. So it can also be written as 1 by z2 is equal to x2 divided by x2 square plus y2 square comma minus y2 divided by x2 square plus y2 square. So 1 by z2, this is the inverse of z2. 1 by z2 is nothing but inverse of z2. Also, for z1 by z2, where z2 is not equal to 0, can be written as z1 times 1 by z2. 1 by z2 is z2 inverse. z1 into z2 inverse. Now, fifth property, 1 by Z1 into Z2 can be written as 1 by Z1 into 1 by Z2 is equal to Z1 inverse into Z2 inverse. So this is the three forms of 1 by Z1 into Z2. Now sixth, Z1 by Z2 divided by Z3, Z4 can be written as Z1 by Z3 into Z2 divided by Z4. It can also be written as Z1 into Z3 inverse into Z2 into Z4 inverse, because 1 by Z3 is equal to Z3 inverse and 1 by Z4 is equal to Z4 inverse. Now some examples. Solve 1 divided by 2 minus 3i, 2 minus 3i times 1 divided by 1 plus I. 1 divided by 1 plus I is equal to 1 divided by 5 minus I. So we have given this. So we can write this as 2 minus 3i into 1 plus I. Now multiply these two. So it becomes 2 into 1 minus 3 into 1 plus I times minus 3 into 1 minus 3 plus 2 into 1 plus 2. So it becomes 1 divided by 2 minus 3. 2 minus 3 is minus 1. Sorry, there is one mistake. Now if we multiply these two numbers, 2 into 1 minus 3 into 1, so plus 3 plus I times minus 3 into 1 minus 3 plus 2 into 1 plus 2. So it becomes 1 divided by 2 plus 3 is 5, and this is minus 3 plus 2 minus 1, that is minus I. So it is equal to RHS. Now example. Reduce 1 minus I raised to 4 into the real number. Now we know that 1 minus I is a complex number because I present there. So we have to reduce this to real number. So 1 minus I raised to 4 is equal to 1 minus I into 1 minus I into 1 minus I into 1 minus I. So multiply these first two. So it becomes 1 into 1 minus 1 into 1. So it becomes 0 plus I times minus 1 into 1 minus 1 minus 1 into 1 minus 1 plus 1 into this is minus 1 into 1 minus I into 1 minus I. So it becomes minus 2I times 1 minus I into 1 minus I. But we have calculated 1 minus I into 1 minus I, which is minus 2I. Minus 2I into minus 2I. So it is 4I square. So it is equal to minus 4 because I square is equal to minus 1. So we reduce this number to real number. So this number is actually real number, but it seems to be like a complex number. So today's lecture I am going to stop over here. Thank you.